Coalescent Theory is a brilliant theory that uses mathematics to yield a beautiful marriage in biology and math. For example, it explains why us humans and chimpanzees are so closely related to each other. Let's look more into it. So, to back up a little bit, all animals have genes, which are sections of DNA that code for specific traits, such as eye color or ear size. You inherit these genes from your parents. Genes have specific copies, or variants, inherited from the parents. The variants are known as alleles. Now, alleles code for the actual physical trait in an organism. So, if the gene was for eye color, there could be two alleles, green eyes or blue eyes. Only one allele is expressed in the organism, depending on whether the allele is dominant or not. Coalescent theory models how the alleles in a population of individuals could relate to each other through a common ancestor. How cool is that? Let's look at an example. Let's consider a population of N humans, in which each human has two alleles. Now let's look at a specific allele in this population. In this case, how about the allele for black hair? Essentially, we want to trace these alleles back through generations until they coalesce or come together at a certain point. One important thing to note is that the alleles are inherited randomly. So in this situation, the preceding generation, which also has N humans, matched for 3 alleles. Wow! We can keep going back until the alleles coalesce into one. This point is known as the MRCA, or most recent common ancestor. What is the probability for coalescence? Well, this is where the math meets the biology. Good news! There is a beautiful equation to explain it. Don't get it? Let me see if I can break it down for you. By going back to our first example, we see that there are N humans in each generation, and 2 alleles in each human. So that means the probability that an allele in the previous generation is a parent of 2 alleles in the current generation will be 1 out of 2N, or 1 parent allele out of the total alleles in the population. Then, the probability that the allele is not the parent will be 1 minus 1 out of 2N, since 1 is the highest probability, or 100%. By putting the probability that the allele did not match to the power of generations that the allele did not match for, and multiplying that by the original fraction, we get this beautiful equation that shows us the probability of an allele match with regard to number of generations back. So, all in all, by figuring out where an allele coalesces into a common ancestor, we can figure out why humans and chimps are similar. By finding the common ancestor for an allele in each species population, we can trace the same allele back until it coalesces. At that point, my friends, is our most recent common ancestor, shared by both us, humans, and our close cousins, the chimps. And that's all there is to the coalescent theory. It brilliantly explains how species relate to each other, which might explain why you act like a monkey sometimes.